Today is our introduction to polynomials. In this lesson, we will discuss important terminology that will be used throughout the chapter. Once we are done with introducing the terminology, we will then discuss how to add and subtract these polynomials. The first definition we will talk about is a monomial. This is a number variable or product of numbers and variables that have only positive whole numbers as their exponents. Some examples of a monomial would be terms such as -4, x, -4xy, and even say 1/2 x squared y to the third. All of these are monomials because they are basically numbers, variables, or product of numbers and variables that, if you look at each of them, all of our exponents are positive whole numbers. Okay, your exponents cannot be variables here. Now, a polynomial. If we take a bunch of monomials and add and subtract them together, we would create a polynomial. A polynomial is a monomial, meaning you could have a polynomial with one term, or the sum/difference of one or more monomials. If we were to take, say, the term 3x, this would be a polynomial because it's a polynomial with one term. But we could actually take another example such as 3x squared plus 5x minus 8. This would be a polynomial with three terms. But notice how we are taking these monomials, 3x squared, 5x, -8, and we're linking them together by addition or subtraction. That's what makes this a polynomial. Now, you've heard me probably say the word term versus monomial a couple of times. Anytime you hear the word term during this chapter, we are basically referring to the monomials that are linked by addition or subtraction in a polynomial. So when I look at this example up above, 3x squared plus 5x minus 8, this polynomial has three terms, those terms being 3x squared, 5x, and -8. So that is probably the most important out of those three that we need to know because it'll be used a lot throughout the chapter. Now, we name polynomials two different ways. First, we name them by the number of terms they have. One important name that we give it is a binomial. In a binomial, if you think of the prefix bi, it means two. So a binomial is basically a polynomial with two terms. An example of this would be 2x plus 3. 2x is one term, 3 is another term, so it's a polynomial with two terms, which instead of saying a polynomial with two terms, we refer to that as a binomial. Next, we have a trinomial. Well, what's the prefix for tri? 3. Therefore, a polynomial with three terms is what we refer to as a trinomial, such as 2x squared plus 6x minus 5. If you look, here's one term, two terms, and three terms. Another way we name polynomials is by their degree. Okay, the first thing we're going to look at is what is the degree of a monomial. Well, we take the sum of the exponents of the variables. That would be the degree of the term. Now, a constant is kind of unique. When we say a constant, we just mean a number. This number does not have a variable expression. Therefore, we would say this term 3, since there's no variable expression, would be degree 0, which we name as a constant. Now, a lot of other terms will have variables. So how do we handle those in terms of naming them by their degree or assigning a degree? Well, if I give you the example 6x to the 5th, we would say the degree on this term is 5 because the exponent on the variable is 5. So this would be degree 5. Now, what happens if we have a term with more than one variable? Say 7x squared y to the third. Well, with more than one variable, we take the two exponents on x and y and we add them together. So 2 plus 3 equals 5. Therefore, this is a degree 5 monomial. Now, that brings us to the degree of a polynomial. Well, a polynomial could have up to, say, 8 terms. How do we determine what the degree of the polynomial would be? Well, what we basically do is we take each individual term and find the degree of the terms. The term with the highest degree is the degree of the polynomial. Such as, let's take the polynomial 5x to the fourth plus 3x to the third minus 8x squared plus 6x plus 5. When I take the degree of each term, the degree of this term is 4. The degree of this term is 3. The degree of this term is 2. This is 1, and this is constant. Well, the highest degree in this polynomial is 4. Therefore, this is a degree 4 polynomial. Okay. Now, there are a lot of polynomials that we use quite often. Some that we call binomials and trinomials. But then we have certain polynomials we use a lot that we name by the degree. Okay, first, we already talked about it up here, which is a degree 0 polynomial, which would be just a constant. Now, once we have a degree 1, that means you have to have a variable in the expression. We refer to this as a linear polynomial. So, an example of that would be 4x plus 3. The highest degree in this polynomial is 1. Therefore, it's a degree 1 polynomial, which we state as a linear polynomial. A degree 2, okay, has to have a degree 2 term in the polynomial, such as 5x squared plus 6x minus 3. The highest degree in this is 2, and we say a degree 2 polynomial is a quadratic. So every polynomial whose highest exponent is 2 is known as quadratic. A degree 3 polynomial we call cubic. And of course, obviously, to have a degree 3 polynomial, we'd have to have an exponent of 3 being the highest exponent in the polynomial. So, 2x to the third plus 6x minus 8. Okay, this would be a degree 3 polynomial, not because there's 3 terms, but because the highest exponent is 3. Now, once we look at these polynomials, it's important to know what standard form of a polynomial is. Standard form is taking the polynomial and writing it in descending order by the degree. So if you look at all the examples I use, I always start with the highest degree and work my way down. For example, an example of a polynomial written in standard form. Okay, so standard form would be 5x to the third minus 6x squared minus 8x plus 1. We start highest degree, second highest, third highest, and then our constant will always be last. Not in standard form would be a polynomial written as, say, 8x to the second minus 5x to the third plus 2x minus 1. If I look, is this in descending order by degree? Absolutely not. Now, we could write that in standard form if we wanted to. Okay, we know this term would have to go first, but we always have to keep in mind of the sign to the left of the term. So if we were to write this in standard form, negative 5x to the third would go first. You have to see that the sign to the left is negative, plus 8x squared, plus the 2x, and then minus the 1. Now it is written in descending order by degree. Now, if you look at the example of the polynomial we have below, 2x to the third plus x squared minus 5x plus 12, let's kind of talk about everything that we have here. First, leading coefficient. If you go back to the beginning of Algebra 1, we talked about coefficients. Any term I have, say 3x, okay, has a coefficient. Coefficient is the number in front of the variable expression. Okay, so when I look at this term, 3 is the coefficient. Now, in a polynomial, the leading coefficient is the coefficient of the first term, or the term with the highest degree. Okay, so basically if you take the polynomial, you write it in standard form. If you look at the very first term, the coefficient of that term is the leading coefficient. We already stated the degree of a polynomial is basically the exponents on the variable expressions. But the degree of the polynomial is the highest degree within the polynomial. Then we have the constant term, which is always the term without any variables linked to it. Now, if you notice here, we point out all the terms. This has 4 terms, okay? And you know, we kind of didn't talk about it up above, but once you get above 3 terms, we just say a polynomial would say 8 terms would just be a polynomial. We only name polynomials with 1 term as a monomial, 2 terms as a binomial, 3 terms as a trinomial. Once we get above 3, we just say they're polynomials. Now, as we just talked about here, okay, how do we write them in standard form? Well, basically what we look at is, let me fix this, is we look at the degree of each term. And we want to start with the highest degree. Okay, and remember, the exponents must be written in decreasing order from left to right. So in descending order by degree. So this is the highest degree 3. So that would have to be first. But remember, always take the sign to the left of the term. So the sign to the left is negative, so we would say negative x to the third. What's the next term? Well, degree 1 would come before a constant, so we would take the positive 15x. Since it's positive, we would add it. And then finally, the constant would come last. Since it is positive, we would go ahead and add it. Now this polynomial is written in standard form. Just, you know, refresh our memories. We would call this, how would we name this by the number of terms? Name by number of terms. Well, how many terms do we have? Well, we have 1 term, 2 terms, 3 terms, and a polynomial with 3 terms is known as a trinomial. Now, what would the name by degree be? The name by degree, oh, what's the highest degree? 3. What do we call a degree 3 polynomial? A cubic. Okay, so that's writing in standard form. Now, if you could pause the video and go through and look at this chart and try to answer these on your own, okay, and then replay it and basically check your answers. So go ahead and try it on your own. Now, the first one, here's our expression 9. You want to classify these polynomials. First, is this a polynomial? The answer to that is yes. Okay, if I classify it by the number of terms, it's a polynomial with 1 term. Therefore, it is a monomial. The degree of a monomial, alright, because this is a constant, or it is degree 0. Degree 0 we call constants. The next one, 2x squared plus x minus 5. Well, is it a polynomial? All of our exponents look good, so yes, this is a polynomial. And if we name it by the number of terms, how many terms are there? There's 1 term, 2 terms, 3 terms. What do we call a polynomial with 3 terms? A trinomial. If I look at the highest degree is 2. Therefore, if we classify it by degree, this would be a quadratic. Next, is this a polynomial? Think about it. First term looks good, but what's wrong with the second term? Well, if I look at the exponent on 8, that is a variable. And if you go up to the definition of a monomial or a polynomial, all the terms have to have exponents that are whole numbers. This is not a whole number, therefore this is not a polynomial. Next one, in the definition up above too, they said you cannot have negative exponents. Therefore, because the exponent on n is negative 2, that would not make this a polynomial. And the last one. Okay, is this a polynomial? All my exponents on the variable expressions look good. And if I look at this, this would be a polynomial. If I look at it, there are 2 terms. What do we call a polynomial with 2 terms? A binomial. And if I look at the degree, well, what is the degree of the first term? Well, the exponent on b is 1. If I add the 1 and the 3, that would be degree 4. In the second term, okay, if I take the exponent on b and the exponent on c, add them together, that would be a degree 5 polynomial. Well, what term has the highest degree? The 4b to the 4th, c to the 1st, which is degree 5. So this would be a degree 5 polynomial. So all of our terminology that we've discussed up above here, you're going to hear it quite often. So it is very valuable to make sure you study that throughout the chapter. So let's move on. How do we add and subtract these polynomials? Well, basically we've been doing this since day 1 of algebra. Adding polynomials is basically combining like terms. The only thing is, you'll see that if I'm adding polynomials, these would be in parentheses for one polynomial, and these terms would be in parentheses to represent another polynomial. So this is a polynomial, this is a polynomial, and you see we're linking these polynomials by addition. Well, adding polynomials is real easy, because all we're going to basically do is we're going to drop the parentheses and go ahead and combine like terms. So as we look above at this example, we are adding them. Now, once I drop the parentheses, I would get 2x to the 3rd minus 5x squared plus x plus 2x squared plus x to the 3rd minus 1. Now, going back to earlier in the year, combining like terms, basically all we do is add and subtract the coefficient of the terms with this identical variable expressions. And if you remember, we used to we put different shapes around like terms. So if I look at 2x to the 3rd, are there any other x to the 3rds I can combine it with? Yes. This x to the 3rd. Then I'll move on to circles. Put a circle around negative 5x squared. What else can get a circle? 2x squared. Can x be combined with anything? No. Can negative 1 be combined with anything? No. Now when we write these, we want to write them in descending order to put them in standard form. So we start with the highest exponent, which is 3. So 2x to the 3rd plus x to the 3rd. Okay, what the coefficient on x to the 3rd is 1. So 2 plus 1 is 3x to the 3rd. Now, I like to cross them out and let myself know that I used it. Because if I have any left over at the end, I know I have to go back and fix it. Now, negative 5x squared plus 2x squared minus 3x squared. Cross them out. I've used them. I have nothing to combine x with, so it's plus x. And then I have nothing to combine negative 1 with, so I subtract it. And this would be the sum of these two polynomials. I would like you to take a minute to go and do the practice problems. So, looking at the two practice problems, the first one, since we are adding the two polynomials, we will go ahead and basically drop the parentheses. And when we do that, minus 6 plus x squared plus 4x plus 10, and then I go ahead and combine like terms. 3x squared plus x squared gives me 4x squared. X plus 4x is 5x. And negative 6, let's do a different shape around that. Negative 6 plus 10 is positive 4. And we have added these two polynomials. Next, as you look here, with adding them, if you can go ahead and basically combine like terms without rewriting it by dropping the parentheses, I don't mind if you go ahead and just say, okay, 4x to the third plus x to the third is 5x to the third. Cross them out. I've used them. Now, I started with x to the third, so x to the second has to go next. Therefore, I have plus 2x squared. Now here, if you notice, common mistake that's made with these is when you're using pencil and the ink is in black, when you make your shapes around here, make sure you don't change minus signs to look like positive signs. So, 2x squared is done, but 5x minus x is 4x, and negative 2 plus 3 is positive 1. I know you guys are really good at this, and you probably got those correct. Congratulations. So moving on. How do we subtract polynomials? Well, basically it's very similar, but the only thing is, when you have this minus sign in front of the set of parentheses, if you remember, we have to distribute this minus sign. Anytime you are subtracting polynomials, you have to distribute the negative. Now when we distribute a negative, basically what that does is it changes the sign of all the terms inside the parentheses. Now you only distribute the negative to the parentheses on the right. In math we always work left to right. Always keep that in mind. So looking at this first example, do I have to distribute anything to the first set of parentheses? No. So I basically drop the parentheses and rewrite it. Now, the second set of parentheses, I have to go and distribute this negative, which means all of these signs are going to change. A negative times a negative is going to be a positive 2x squared, so I add the 2x squared. Negative times a positive 2x is going to be minus 2x. And a negative times a negative 4 is a positive 4. Well, once I distribute the negative and I get rid of the parentheses, now I can go ahead and combine like terms. 4x squared plus 2x squared is 6x squared. And negative 2x, nothing to combine with, so minus 2x. 5 plus 4 is 9. And that is how we subtract polynomials. Remember, distribute the negative and then combine like terms. Anytime you do add or subtract polynomials, it's very important to remember to write your final answer in standard form. So, take a minute to try the next 3 examples on your own. So this example here, we will go ahead, distribute the negative, so we end up with 4x squared minus 3x plus 5 This positive 3x squared will become negative 3x squared. This negative x, when we bling this, a negative times a negative is a positive x. Here you have a negative and a negative 8 makes a positive 8. When I combine like terms, 4x squared minus 3x squared is just 1x squared or just x squared. Negative 3x plus x is going to give you minus 2x, and 5 plus 8 is 13. And we are done with that one. Next example, when you distribute that negative. Okay, do I have to distribute anything to the first set of parentheses? No. So 3x to the third minus 5x squared plus 2. Now, this negative 2x squared becomes positive 2x squared. The positive 2x becomes negative 2x. And the negative 6, a negative and a negative make a positive 6. Now, if you wanted to, if you understand exactly what we're doing, I have no problem with you going ahead and just changing the minus sign to a plus and going and changing the signs here. Okay, so you don't have to rewrite the polynomial. Once you do that, you still have to combine like terms properly. 3x to the third. You got negative 5x squared plus 2x squared is minus 3x squared. You have your minus 2x and then your plus 8 right here. And you are done here. And up above you notice you get the same thing. 3x to the third. You have negative 5x squared plus 2x squared. Okay, which is going to give you negative 3x squared. And you have your negative 2x. And then 2 plus 6 is 8. No matter which way you do it, you get the same answer in the end. Now the last one here, we actually have 3 polynomials that we are adding or subtracting. When I look at it, I take it one by one and I ask myself, in this polynomial, do we have anything on the left we have to distribute? And the answer to that is no. So we drop the parentheses and we rewrite the polynomial. The second polynomial, you look, oh, there's a negative. See, we don't have to distribute positives because the positives won't change the signs. But negatives, the signs will change. So this positive 10x to the third will become negative 10x to the third. Negative 2x squared will become a negative make a positive 2x squared. Negative times a positive is a negative 4x. Negative times a negative is a positive 5. And then when I look at this set of parentheses, do I have to distribute anything? Well, technically I could, but it would not change anything because distributing a positive basically doesn't change anything. So I can just rewrite the x or the terms as is. And once I have this, I go ahead and combine like terms. 12x to the third minus 10x to the third gives me 2x to the third. Then 2x squared plus 4x squared gives you 6x squared. 5x minus 4x will give us positive 1x. Then 6 or 5 minus 6, sorry, is going to be negative 1. And here's what we get when we simplify this polynomial. So subtracting is not very much different than adding. The only thing is you have to remember to distribute that negative. Now, there are some basically ones where we completely simplify, meaning we don't just have negatives to distribute. If I look at this next example, example 1, what do I have to the left of this polynomial? I have this 2. Well, what can I do with this 2? Anything that's linked to a set of parentheses by multiplication, we distribute. So everything in this set of parentheses has to get multiplied by 2. So I'd get 2x squared plus 6x plus 10. Now, when I look at the second set of parentheses, what is to the left or linked by multiplication to this set of parentheses? Well, that's that -3 there. And I have to read that as -3, which means I'm going to distribute that -3 to each term in that polynomial. So -3 times 2x squared would be -6x squared. -3 times 6x is -18x. Now I can go ahead and combine like terms. Sorry, that's -6x squared. So 2x squared minus 6x squared will give you -4x squared. Remember, we have to write these in standard form. Then 6x minus 18x is minus 12x, and then your plus 10. And there is our answer. Remember, we just finished up the chapter with multiplying, variable expressions where we added exponents. When we combine like terms, we do not change the exponents on the variable expressions. The second problem here, very similar. Okay, first, this set of parentheses here, where this polynomial is going to have the 9 distributed. So, 9x to the third minus 45x squared. 9 times -2 is -18. The second polynomial will have 8 distributed to it. So 8 times 3x squared is 24x squared. 8 times 2x is 16x. And 8 times 1 is 8. Again, once I have all my distributing done, okay, that means I get rid of my parentheses and I can go right to combining like terms. Do I have any other x to the thirds? Nope. So 9x to the third. Then you have your -45x squared and 24x squared, which would give me -23x squared. Oh, sorry, 21x squared. Then you have your 16x. Oh, nothing can be combined with that, so I just rewrite it. And then -18 plus 8 is going to give me -10. So I distributed, combined like terms, and made sure I wrote it in standard form. And that is the end of this lesson. Tomorrow we will focus on multiplying polynomials, which isn't very difficult. It's very similar, but very important. It is your duty now to go and complete the extra practice. Have a good night.